Hi everybody, today we're going to be covering dynamic programming and we're going to do a problem after. First, you want to remember that dynamic programming always has a lookup table. This means an array, so you always store your solutions in an array. This is called memoization, or as I like to call it, it's memorization. Basically, the array is memorizing all of the past values. So as you find a value, you store it in the array. The second thing that we want to remember about dynamic programming is that we always use our past solutions to get our current solution. That's the whole reason we have the table. We store our past solutions and we use it to get the current solution. Always. Alright, let's go ahead and get started with a problem. So this is from Leetcode. It's called Climbing Stairs. We're going to first make our lookup table. So this is an array, and you want to think about each case. So usually n equals 0 is a case, but the 0 case is a little difficult usually, so I save that till the end, for the end. So I'm just going to start with like n equals 1. What would happen if we had one stair? How many ways can we get to that stair? So think about it. If you have one stair, there's only one way you can get to it. You just take one step. So that one's pretty easy. So in our table up there, in our array, for the index 1, we would store 1. I guess I'll just do that at the end. So now we're going to say what happens if n equals 2. How many ways are there to get to the stair? Well, you can take one step and then another step, or you can just take 2 steps. So there are 2 ways. And the whole time you're doing this, try to think in your head, how can I use my past solutions to get my current one? So for n equals 3, we can do 1 plus 1 plus 1, or we can take like 2 steps and then a step, or we can take 1 step and then 2 steps. So there are 3 ways. So as we reach n equals 4, I want you all to kind of think of how we're using maybe our past solutions. So I'm just kind of going to write out all the different ways. And these are kind of hard to think of. You just have to kind of think, you could take 1 step and then another and then another. You could do 2 and then 1 and then 1. You can do like another 1 and then 2 and then 1. And I kind of want you guys to notice, do you see how the fourth for n equals 4, you basically, it's like coming to the 3rd step and then you can just add 1 more step. So if you already made it to the 3rd step, you just have to take 1 more step to get to the 4th step. Do you see that? So if you're on the 3rd step, you just have to take 1 more step. Similarly, for n equals 2, if you're on the 2nd step, you just have to take 2 steps to get to the 4th step. So since you just add 2 steps to everything in n equals 2, and if you're confused right now, just try for n equals 5. Try using the past solutions to get that. And then you always have to come up with like an equation before you code your solution. So for us, how do we get to the nth step? Well, you can either jump 1 from the previous step or 2 from the step before that. So I'm just labeling this. This is my lookup table, my array. So just to reiterate, to get to lookup at spot n, however number of ways there are to get to spot n is adding the number of ways from the previous step plus the step before that. And you kind of have to think about it and kind of work it out yourself to understand it a few times. But that is what this is. And just keep putting bigger numbers for n so you can make sense of it. So for myself, it just made sense to put that there are 0 ways to come to, if there are 0 steps. And then, for n equals 1, we got 1 way, so we put 1. And then n equals 2, we put 2 ways. And then for n equals 3, there are 3 ways. And n equals 4, we got like 5 ways. And so, based on our equation, it looks like you just add the last 2. And so that's what I noticed for this equation thing to work out. For n equals 0, it should be 1. And you'll find yourself doing that where you'll kind of change what you thought it was. And for this example, n equaled 7, so our array was actually size 7 plus 1, so we include the 0 case. So we would return the very last element. And that's dynamic programming. Thank you so much.